Good morning, students. So now we'll move on to the next module, that is the fourth module, cams. So in my previous videos I have already informed you that we have completed first two modules. So first module was completely theory, then second module you have exclusively problems, one problem carrying 20 marks. Then the next module, that is, I'm directly moving on to fourth module. For time being I am omitting the third module, so we'll see the fourth module. Fourth module, it's all about the sum again. One sum will carry 20 marks problem. So for more understanding of the problem, we require to know regarding the theories. So theory is the basic concepts regarding the cams. So we'll move on. This is cams. So we'll see what is a cam is. Cam is, as you can see in the diagram figure there. So cam is nothing but it's a rotary device. So you have a cam which can rotate. So you can see here, when this is rotating, it will convert that rotary motion into another device that is called as follower. So rotary motion can be converted into oscillatory motion of the follower, or translation of the follower, or simply again the rotation. So like that you can convert the motion, rotary motion, into another motion in the follower, and like that it can move. So you can see the application where and all we are using. So it's used for high speed applications like IC engines. So lot of places we will be using. So IC engines will be the common area where we can use this device. So you can see in the diagram here. So you can see here, this is the cam device, you can see. So here is the cam which is rotating, and due to its rotation you can see the follower is translating, or it is just reciprocating up and down. So you can see the rotary motion is converted into a translation, or we can say it as it is just a linear motion. So this is an example. This is a very good application where we can see this device. You can see this is used for opening and closing. You can see the valves present over here. So the valve is opened and closed using this device. You can see as the shaft is rotating, shaft is in turn connected to the, you can see the pulley here, a pulley arrangement, and it is again pulley is connected to the shaft, small shaft again. So there you can have the rotary device as the cam. So cam is followed by this follower. So due to that motion, so you can see what happens, it can open and close. So timing of opening, how much duration this valve should be opened and how much duration it should be closed, is based on designing the cam. You can see the cam here, you can see a protruding kind of thing there. So it is based on how much duration you want to open or how much duration you have close. So based on that we will decide the cam. So in this module we are going to study that only, because in the upward motion how much it should move, the follower should move, and in the lower motion, downward motion of the follower, so how much that follower can move. So based on that we will design the cam profile also. So designing of cam profile is what we are going to see in this. So for that we'll see what are the important things we require. So you can see the classification of cam mechanism. So there can be three. One is this one, rotating cam is there. Then that rotating can be converted into translating follower. So when cam rotates, follower translates. Translator means just linear motion or reciprocation. Now second type is rotary motion, can be converted into oscillation, and third is translation, again converting into translation. I will just show you the example. So you can see the example, first example here. What happens here is, this is a cam. So this cam is rotating. Due to this rotation you can see what happens, the follower, it is just moving up and down, reciprocation or translation. So this first type. Next type, I don't have the animation here, but you can just imagine how it is moving. So this is the rotation of the cam. Due to the rotation of the cam, it just oscillates like this. You can see this can oscillate with respect to this pivot point. Third one is translation is converted into translation. For example, you can see the movement, how it is moving this base, and due to this surface, slanting surface, you can see how it is constrained to move in a linear direction. So hope you already know that this cam is also an example for higher pair. Gears are also example for higher pair. So you know what is a lower pair and higher pair is. Lower pair means you have the surface contact or full body contact, but higher pair means you have just point contact or you have a line contact only. So you can see here, when this kind of device is rotating, you can see the contact between the cam and follower is just a point or sometimes a line. So in that type of contact is there, then it comes under higher pairs. So now we'll move on to classification of the cams. So you can see the three types of classification. Radial, so with the diagram we can explain. So radial cam, what happens means, in radial cam you can see the axis of the cam and how the follower is moving. So both are perpendicular to each other. Direction of the axis of cam and how the follower is rotating or reciprocating, it will be perpendicular to each other. So that type of cam is called as the radial cam. Now cylindrical cams are there. So in cylindrical cams, the both direction will be parallel. You can see how it is oscillating and how the axis of the cam is. So both will be parallel to each other. Then it is cylindrical cam. N cams are there. N cams means same as cylindrical cam only, but the only thing is you can see it will move along the periphery. So along the periphery of the rotating device, this is a rotating device or the cam we can call. So along the surface it is moving. So that kind of cams are called as end cams. Now we'll move on to the follower. What is a follower? Follower means it follows the path of rotation of the cam. So how the cam is rotating, this will be followed by the follower. So now we'll see the different types of followers. Just like we have seen the different type of cams, we have different types of followers also. So you can see one by one we'll see. So this is the first example, knife edge follower. So this part you have to keep in your mind, because this will be very helpful when we do a problem, because in problem they'll be telling regarding the type of follower. So based on that we have to write the question. So this part, so we'll make little more clear. You can see, so in this mechanism you can see how the surface of the follower, edge of the follower, it is just like a knife edge. So you can see here how the edge is. So it's very sharp and just like a maybe a point contact you can expect here, or sometimes the line contact. So that's why it's called as knife edge follower, but the cam will be the same. So this is second type. You can see it is a roller. So instead of that edge, knife sharp edge, you have a roller here, and you can see again what happens, rotation is converted into linear motion of the follower. And this is third type, flat faced follower. You can see here, so the face of the follower is just like a flat plate. So it's a little more bigger surface contact you can expect in this type of cams. And finally it is a spherical faced follower. You can see how the surface of the follower is. So you can see it's like a spherical surface, it is fixed to the cam. So in this four types, you can see the four types are mainly knife edge, roller, flat faced and spherical face follower. In this first two type is most important types of follower, that is knife edge and roller. So you can expect most of the problems is coming under these two categories. Sometimes you can expect the question from flat face follower also, but this two, knife edge and roller is the mostly frequently asked question. That type of profile you have to create. So next one is regarding the path of the motion. So again I can tell this follower and follower can be divided, classified some 2-3 types. according to the shape of the follower, it is knife edge, roller shape, or flat faced, and spherical shape. That is one category. And second category is, you can see here, second category is based on the path, how the follower is moving, the path of the follower. Again, you can classify into two types. One is radial follower and second type is offset follower. So from the name, you may be clear what is radial and what is offset. So in radial, what happens is, when the motion of the follower is along an axis passing through the center of cam. That means you can see how this is reciprocating like this. The follower is reciprocating like this, and that path is along the center. You can see that path of the reciprocation of the follower is, if you extend that, you can see it is passing through the center of the cam. So this type of followers are called as radial followers. And what about offset? You can see here, this is the path of the direction of reciprocating. If you extend that, it is not moving through the center of the cam. So center of the cam is here. That means the center is at some distance, some offset distance from the follower. So that type of followers are called as offset followers. Next is regarding the basis of motion. So you can call it as, when the follower is just reciprocating or moving up and down, it is called as reciprocating or translation. Or sometimes you can see oscillation of the follower. So that type is called as oscillating or rotating followers also. So that is regarding the classification of the cam, different types of cam, different types of followers, how you classify followers. So those things. Now we'll go into the cam nomenclature. That means, what are the basic things you have to keep in your mind when we go draw the cam profile. So first and foremost thing is the cam profile. You can see here, cam profile, it is nothing but it is the outermost surface of the disc cam. So you can see the cam profile, this is the outermost, how it is moving. The cam, what is the outward surface when you consider the sender? So from there, how much outward it can move. So that path is called as cam profile. Next one is base circle. Base circle, you can see base circle, this is the base circle, that is the shortest circle. That means circle with shortest radius from the cam center to any part of the cam profile. So that is the shortest circle you can draw inside a cam profile, that is base circle. So next one is trace point. Trace point means, you can see here, this is for example for a roller follower. Roller follower, this is the point where the axis of the cam, and you can see where the follower is present. So that is a starting point of the follower motion. Okay, it is a point on the follower and its motion describes the movement, and that point describes, you can see the trace point here, here, like a lot of points you can see. So that points are the point which is describing how the cam will be moving. You can see here, the cam will be coming like this, it is going up, it is coming down, again it is joining the starting point. So like that. So that points, the various points which is describing the motion of the follower is called as trace point. So now when I am explaining, you might feel some difficulty, but when we draw a lot of problems, so that time it will become more clear for you regarding the all basic concepts. So just keep in your mind regarding the important nomenclature terms. Next is pitch curve. What is pitch curve? Pitch curve is the path generated by the trace point. So I have explained you what is a trace point. So if you join all the trace points, you can get a path. So that path is called as the pitch curve. So if you join all the points, that is not the profile of the cam. Profile of the cam is, if you join the base, if you join the base of all the small circles, that is the profile of the cam. But pitch curve is the trace point. You can see different points at the center of this small balls, you can see here. So if you join all those points, that will become your pitch curve. Next is prime circle. Prime circle is the smallest circle from the cam center. So this is the cam center. From the cam center through the pitch curve. You can see the pitch curve. So the smaller circle which you can draw passing through the pitch curve and through the center, so that will be the prime circle. So prime circle will be the smallest circle in the case of the roller follower. Next is pressure angle. So pressure angle is nothing but, see, if you can see here, pressure angle is the angle between direction of the follower movement. So what is the direction of follower movement? You can see here, example here, this is the direction. If you take one point, for this point the direction of follower motion will be like this. This is the direction. You can see here it is like this, up and down. So whichever point you take, follower will be like this. Okay, so here in this point the follower, that means, so don't get this confused, that in this diagram follower will not move around the cam. Follower will be here only. Follower will just reciprocate like this. Only the cam will rotate. So it's very difficult to show you the rotation of the cam. So that's why we have been showing the roller how it is moving, because this, what happens is, when this surface comes over here, what is the position of the follower? That is what it is described here. Okay, so that is what, for example, when this surface comes over here, the movement of the follower will be like this, and you will be having a pitch curve, the point of the pitch curve. There, if you can see this is the pitch curve. So there, if you draw a perpendicular normal to that pitch curve, so you can get an angle between that follower direction and the pitch curve, normal to the pitch curve. So the angle between those two is known as the pressure angle. And next one is pitch point. Pitch point is the point at which you can expect, this is the pitch point. Pitch point is the point at which you can see two circles. One is this big circle and another one is this small circle. Both are meeting at one point. That is one definition you can give, or you can give as that is the point at which the pressure angle will be maximum. You can expect the maximum pressure angle for that point. So that is called as pitch point. Now pitch circle is a circle drawn from the center, cam center, and passes through the pitch point, is called as, its symbol, this one circle is called pitch circle. And stroke, what is stroke? Stroke is the maximum distance. You can see the follower is moving up and down. So from this point, if you consider this trace point, from this point, what is the maximum distance upward it can move, that follower can move? That is called as a stroke length or the stroke. Now we'll move on to the motion. So you know that when a cam is rotating, follower can reciprocate, or can rotate or can oscillate. So when the cam rotates, follower will move up and down. So when the follower is moving upward direction, upward movement, it is called as a rise, or it is also known as outstroke. It is moving up from its basic initial starting position. Now next is downward movement. From the starting position it reaches up. Now from up position it have to come down. So that again, that movement is called as downward stroke or downward movement, or fall we'll call, or return stroke. Then you can have a third condition, third case, where it is neither moving upward or neither coming downwards. It's just resting at that point itself. So that point is called as dual. So you have three types in which the follower can move. Either it can move outwards, it's called as outstroke, upward motion, rise. It can come down from there, this is called as fall or return stroke. And for example, it is moving outstroke, then for some degree of rotation of the cam, follower is held on that position itself. That position is known as dual. That means it is neither it is moving up from that position, either it is coming down. So that is called as dual. So we'll move into the next concept, that is the type of follower motion. So I hope whatever I explained till now, it is more clear for you, like what are the different types of cams, what are the different types of followers, and followers are classified based on the type of motion, based on the motion and whether it is situated along the center of the axis, like that some classification we have seen. After that we have seen some basic terms which is present or which you have to keep in your mind when we draw a cam profile. For example, what is a base circle, what is a prime circle, what is a pitch point, then what is a trace point, like that some basic terms you have to keep in your mind. It is not important that you have to study every terms, but you have just keep in your mind, but importance can be given to this which I explain now. Now we'll move on to the next type, that is, it is the types in which you can expect the follower motion. So you can see a 4 types here. So your question, one question 20 marks, they can ask you from this 4 types. So your follower will be moving, it will be having a uniform motion, that is constant velocity, or it may either move in simple harmonic motion, or it can uniformly accelerate, it can reach one position, keep that position for some time, it can uniformly decelerate or retardation, that can be possible, or it can move along a cycloidal curve, just like a curve in the form of a cycloidal curve. So in this 4 types you can have the follower to move. So we told that follower will move upward, up, down, like that, will move upwards and downwards. So when it is moving upwards or when it is moving downwards, how it is moving, whether it is moving with constant velocity or whether it is moving with a simple harmonic motion or UARM, that is uniform acceleration retardation, or cycloidal, like that. It can come down also, that is downward stroke or out stroke, fall, return stroke. So it can happen in this 4 ways. So we see what are the different types of this 4 motions we can expect. So this is the first type of uniform motion or constant velocity. Uniform velocity also we'll call first type. So it's very basic. So you have to keep in mind that whenever we get a question for constructing the cam profile, so all the cam profile will be drawn based on this displacement diagram. The displacement diagram is very important when you draw a cam profile. So here you can see in displacement diagram, you have to consider, first of all we'll construct a box like this, rectangular box, and this rectangular box denotes the rotation of the cam. For example, you can see when a cam completes one rotation, when a cam is completing one rotation, that is 360 degree it is rotating, it will move how the follower is moving. You can see if you can take this first thing as the outward stroke, you can see it is moving up. The follower from the starting position, it is moving like this up, it reaches the up. So that means first 90 degree of the rotation of the cam, the follower is moving like this, coming up, reaches the maximum stroke, and then when the cam is again rotating for another 90 degree, it reaches its same position. It is not moving up or down, that is called as dwell period. This dwell period, this is out stroke, this is dwell period, and for the next remaining again 90 you can take. So 90 plus 90, it is 180, 180 plus again 90, 270. So remaining 90 degree, it comes down like this, that is fall or return stroke. Then question will tell us and the remaining period, what happens, it will be dwell, because there is no rise or fall, you can see here. So like that you can have the displacement diagram, and based on this diagram we will draw the cam profile. Okay, so uniform velocity motion means you can see it is uniformly rising, reaches the dwell period, uniformly falls down. So that is the uniform motion. Second type is simple harmonic. You can see here again we are drawing the same displacement diagram, rectangular diagram, with the stroke length. They will be also telling how much the stroke length is, how much it is moving outward. So all this measurement we have to draw with the correct measurement. We can see when we explain a problem. So you can see how the curve is. You can see in the outward stroke, it is just like a rising curve, sine wave curve. You can see that is why it is called as simple harmonic motion. Then for some time it is dwell. You can see theta O means angle for outward stroke, theta R means angle for return stroke. So this is theta d, you can write, that is dwell period, angle for dwell period, and you can see it is falling down again with SHM, and remaining period, that is dwell again. So you can see the whole thing, this whole direction will be for 360 degree of rotation of cam. So for sometimes in question they will ask you to write down the maximum velocity of the follower during the outward stroke. So this is the formula. So pi omega n value will be given, so you can find out the value of omega. Yes, is stroke length. Stroke length is nothing but this distance. This will be some 4 mm or 10 mm, whatever it is, as per the scale we will be writing. So that value you have to write here. Divide by 2 theta outward. Theta outward will be the duration of outward stroke, that is, if it is 60 degree is the outward stroke, that means first 60 degree of the cam rotation you will be having the outward stroke. So that 60 degree you have to convert into radian, that is pi by 180. So you will get into radian. So multiply by 2, you will get the maximum velocity during outward stroke. Similarly, you can find out the maximum velocity during the maximum acceleration during the outward stroke. Put in the equation. It is somewhat different. The equation is, so divide by 2, theta out square will be coming here. So same thing, square will be coming except for the s. So you can get the value of maximum acceleration. So these two values are for outward stroke. So if you want to find out for return stroke, same equation, only the thing is instead of theta o, here you will write theta r. Remaining everything will be same. So this is the equation to find out maximum acceleration and maximum velocity for simple harmonic motion. Only for simple harmonic motion you can put that equation and you can find out the value. So next we will move on to the next type, that is UARM. UARM means uniform acceleration and retardation. So UARM, the same equations are given over here. You can see the equation for outward stroke, maximum velocity. So this is the maximum velocity for the return stroke, acceleration for outward stroke, acceleration for the return stroke. So you can see that the outward stroke and return stroke, the formula will be same. Only thing is the theta o and theta o will be replaced by theta r. So that is the only difference. And you can see here how you are getting the curve. It is little more linear thing curve. You can see very straight curve. So I will explain you how to draw this displacement diagram. So that will be the first procedure when you draw the cam profile. So we'll explain in detail. So this is just the equations you have to study. Now we'll move on to the last type. It is cycloidal motion. So you can see the curve again. It's not a sine wave. It's a little more straighter curve. So the value of maximum velocity and acceleration is given over here. So you have to study this also. It may ask if they are asking the question only, then you have to find out the value of maximum velocity and maximum acceleration for that type of follower motion. So these are the 4 types. Only these 4 types you can expect in the exam. That is, again I will revise. If you want, you can see here, go back. So these are the 4 types. One is uniform motion. Uniform motion means straight curve up, remain that position, come down straight, just like a linear curve. Then simple harmonic motion, SHM. Then you have UARM is there. Then you have cycloidal motion. So these are the different curves according to what, like in the question they will be telling you, in the outward stroke it is simple harmonic motion, and the return stroke it is UARM. So first you have to draw the curve for SHM for the outward stroke, return you have to draw for the UARM. So like that it may ask, or it may ask the outward stroke will be uniform motion, return motion will be UARM. So based on that you have to draw the curve. So I will explain you in detail how to draw this curve for displacement diagram in the coming classes. So till now you have to be thorough with this concept, theory concept, like what is a cam is. In cam what happens, linear motion or rotatory motion is converted into linear motion, or linear or rotating motion is converted into oscillatory motion, or vice versa. And then what are the different types of cam, what are the different types of followers, classification of followers, then terms present in the cams, and also the 4 types of follower motion. Very important, this 4 types is. So this is regarding the theory of cams. Problems we'll explain in the coming classes.